Hi folks, I guess we are live. I'm just sharing my screen for the rest of the session. Yeah, so the good thing here is just let me know if everything is clear. Am I audible? Can you see my screen? All of that stuff. Just wanted to make sure that everything is clear. Let me just, yeah, I can hear myself. So things are looking good. No issues from my side. Uh, am I audible? Can you please confirm, folks? I have a live session with all the, so we will be using IPython notebooks for most of these code-based live sessions. Again, I have made ample number of mistakes so that I can teach you how to get out of problems and bugs and errors that typically students make. So yes, audible. That's good. That's good, folks. Thank you. Thank you for the confirmation that everything is clear and audible. We'll start in a couple of minutes because the scheduled time is 6 p.m. I'm a couple of minutes early. So any questions you have, just shoot on the on the chat window. I'll try to answer as many as possible. Before we start, we'll start sharp at like maybe 1 or 2 minutes past 6, right? So that sounds good. So I'll share again. I have a IPython notebook which I'll share at the end of it. You can open it using Google Colab. You can run it on your own laptop/desktop, whatever you want later, right? I'll share the link after the live session is over. Okay, sounds good. Again, just wanted to make sure that the objective of these live sessions is very clear. The objective is to help everyone become better programmers, because that is one of the things that we see many students, both from, especially from non-computer science backgrounds, but also students from CS backgrounds lack. So this is a critical skill. You might know everything in machine learning and deep learning. You might be able to prove every mathematical equation, but if you cannot write programs, you cannot get a machine learning job. It's as simple as that. Very often the first round itself for most companies is a simple Python programming round. Very often, in 90% of the cases, right? So you have to be good with some programming language. People are comfortable with Python or whichever language you are in, right? So again, I'll limit the discussion to the topic at hand. Somebody's asking, can we cover data structures and algorithms? Ramana, I think you also emailed us. I don't think we can cover it in these sessions because our objective is very clear. Of course, we will cover some data structures, algorithms, some good problems around time complexity, space complexity, but which are relevant only in the context of AI ML. Because if I start doing data structures and algorithms, that's a beast onto itself, right? We have a course for interview preparation, data structures, algorithms, which is already like what? Which is already 150, 160 hours now, right? So I don't think we'll do justice to students for machine learning and AI roles if I focus only on data structures algorithms. Our core focus will be Python programming for machine learning and AI applications. In this process, we will cover some data structures algorithms without doubt, but the focus will not be data structures algorithms, right? So, okay, sounds good. So what habit can you make to become a good programmer? You just have to code. Like I remember I started coding in 1999. I was in 9th grade then. I was in 9th class. I started, so thankfully I was in CBSE and computer science was one of the options that we could take. I think in 11th and 12th when I joined. It used to be called informatics practice or something like that. Right? I started coding from 1999. I started coding in a language called Visual Fox Pro, which is a Microsoft language. Then I also learned C, C++. Of course, in my BTech, I learned tons of languages, but the only way you become good programmer, it's a very simple concept. The way you become a good programmer is 80% practice, 80% code yourself. By practice, I don't mean see others code. I mean write your own code. Write your own code, right? 20% read others code. Read others code. This is when you're at a beginner level. When you're at a beginner level, 80% you should practice, write your own code. Again, I'll share hundreds of problems by the end of this live session that you can practice from. 20% read others' code. And as you become better and better, as you become a more mature programmer, what happens is you can do, like today, let's take after 5 years of somebody with 5 years experience, right? 10 years and 12 years is slightly more, but once you are comfortable with programming in any programming language, or at least one programming language, once you become slightly more mature, then you can spend 50% of your time reading others' code, and 50% writing your own code. There is no escaping to writing your own code. Of course, when you become, so this is when you become intermediate level, this is basic. When you're at the entry level, this is intermediate level. Once you become an expert level, then probably you can do 30% write your own code and 70% read others' code from open source libraries, right? This is expert level, right? So again, I do most of this because I read a lot of open source code of libraries and things like that. Again, I've been doing this for a quite lot of time, right? So this is what I would recommend. If you're a beginner, I strongly recommend you spend most of your time writing code. I'll share hundreds of problems with you by the end of this live session that you can use from multiple websites and resources, right? 20% read others' code. At intermediate level, 50% write your own code, 50% read others' code, because you can learn a lot from reading others' code. At expert level, this is what you would be doing. Again, you read others' code a lot because you're doing code reviews and things like that, right? So this is a simple rule book that you can follow. Okay, sounds good, folks. Let's dive into the discussion itself. Where are we? Okay. So let's, again, this is the first session in this series. So I've kept it quite simple. I also did not know, I hope everybody can see my IPython notebook. And again, this is the first session in this series. So I've kept it quite simple, to be honest with you. We are only solving some basic Python problems. Some of you who are good programmers may not benefit much from this session. Okay, let me be very clear. So I'm assuming that I've listed it for the 3 live sessions, this live session, tomorrow and day after tomorrow. For the first 3 live sessions, I mentioned that I already showed you in the announcement video that I'm expecting that students know the basics of Python as we listed here, except SQL, right? So what we'll do in this live session is as follows. I have, I think, 5 or 6 problems that I've listed. Again, I didn't know how many problems we can cover in a 2-hour live session. So I kept it slightly open-ended. Let's see how many we can cover, right? If you're able to finish these 5-6 problems quickly, again, for every problem, I'll tell you what I'll cover. If you're able to cover these 5-6 problems quickly today, tomorrow we'll have more problems. We'll do more problems, right? So first and foremost, given a problem, first understand the problem, break the problem into smaller sub-problems. This is very important. And then connect the dots from the sub-problem to coding concepts that you already know. Again, here I'm assuming that you already know basics of Python programming, right? Then I'll walk through line by line of code wherein we are putting everything together. Since this is the first session, I also want to focus more on common errors and mistakes. Okay, of course, I'll also focus on common errors and mistakes in the future live sessions also in this series, but I'll focus more in this live session. I'll also focus a lot on reading function references and fixing bugs. So what I've done in this live session is I've taken simpler problems, but I'm going to spend a lot of time in these issues. Because even when we evaluate students' code at Applied AI course, this is where a lot of people get stuck, right? This is one of the places where a lot of people get stuck. There are other places also they get stuck, but I thought since this is the first session, I'll focus on this so that once we have this out of our way, we can focus on slightly more complex and interesting problems. Okay. So for every problem that I discuss, I'll give a related problem or problems for exercise. Feel free to practice them. If you have time, I strongly recommend you practice them, right? Other thing is I'll introduce new concepts as we need. If there is some concept that is needed to understand a bug or an error message better, I'll introduce those concepts as we need them. I'll not just do theory sessions. I want to do more hands-on sessions now. Very importantly, if you're a good programmer or an experienced programmer, you may not benefit much from this session, right? Because you might already know everything that is in this session. So just wanted to make that clear. If you are a good programmer, maybe if the first 3-4 sessions, you may not benefit much, right? So I'll leave that decision to you. Okay, sounds good. So let's start with some simple problems. Okay, the problem is simple. Add two randomly generated NumPy matrices using loops. Again, one more very important thing is the context. All the problems we pick will be in the context of AI and machine learning, right? I'll try to pick problems that you will, or code snippets that you will have to build as an AI engineer or a machine learning engineer, right? So first and foremost, NumPy is one of the most extensively used libraries in whole of machine learning and AI, along with pandas, obviously, right? So data frames, along with data frames. So I thought I'll focus more on NumPy right away because it's a very simple thing. So I want you to generate two NumPy matrices and add them using loops, not using the plus operator, right? So I'll go slow very beginning and I'll speed up. Again, this live session I'll go a little slow so that everybody can follow me. Even absolute beginners can follow me, but slowly I'll speed up, right? Sounds good? Okay, so first let's think of this problem. Okay, so the problem, I hope the problem definition is clear. I want you to generate two random NumPy matrices and I want you to add them using loops, right? You can't just say, okay, you can't say I'll generate one matrix A1, I'll just use the plus operator and I'll say B equals to A1 plus A2. This is not allowed. You can't use the plus operator on NumPy matrices, right? Let's assume A1, A2 are two matrices, NumPy matrices. You can't do this. You will have to implement it using for loops. The objective here is so that you become comfortable with writing nested loops. That's one of the objectives here. Okay. So let's look at the subproblems here. Let's list down the subproblems, right? The first subproblem is, okay, so I'll do these things, okay? I'll break it into subproblems. I'll keep solving the subproblems one by one. And I'll connect the subproblems to coding concepts. I'll do code walkthroughs and often done mistakes, and then I'll give you an exercise, right? That's the flow. First and foremost, what is the first subproblem? First, we have to generate random NumPy matrices. That's the first thing, right? So let's assume I want to generate two random NumPy matrices, A1 and A2. Then I want to add both of them using for loops. I want to add both these matrices and store the result in B. This is what I want to do, right? So very simple, very easy concept. Okay, first and foremost, okay. How do you create? So the first subtask here, again, I'm going to describe subtasks along with code, along with common errors also. Okay. So first subtask is, let's assume I want to create matrices of size 5 cross 4, 5 rows and 4 columns, right? First task is create a random matrix of size 5 cross 4. If you know the appropriate functions in NumPy, great. If you don't know the appropriate functions, what should you do? First Google search. NumPy create random matrices. I just Googled this in incognito mode. And my suggestion is always read the top 4 to 5 links. Because the first link may not be the best link always. My suggestion whenever, again, what is that task? What is that subtask? Our subtask 1 is create a random matrix. That's the first subtask, right? Or subproblem. Now just simply Google search NumPy create random matrices. That's it. Because we want to create a NumPy matrix and we want to create random matrices. Read through always, when you Google search, don't leave with one link. Be patient, read the top 4 or 5 links. I read through the top 4 or 5 links and this was one of the good links that I found. Okay, let's go to this link, right? So let's go to this link, let's see what they say. Again, so let's copy this, go here, okay. Okay, so it says, okay, how to create random matrix of random numbers in Python using NumPy. Okay, so random 1D array matrix, right? This is 1D array, which is like a vector, right? Then it says 2D matrix. Okay, this looks right. Right, so what did they do? First, look at this code. This is very important for you to understand. Right, look at this code. What did they say? First, they imported NumPy. Then he's saying numpy.random.rand 3,4. Look at the code snippet first. Look at the code snippet first. Right, 3,4. And then they are printing this random array. What did it result in? It resulted in 3 rows and 4 columns. Okay, this seems to work. Please don't just copy paste it. First and foremost, look at what does this function do. NP is nothing but NumPy random rand. Right? What does this function do? Once you find a link on Google, first and foremost, please Google search for it and say, just search that and say Python. Okay, you get the actual reference. It's very important to read function references because that's the best way for you to understand these concepts. It's extremely important. I can't emphasize this enough. So what did I do? I said import numpy as np, and I'm using this. But please don't copy paste code, because if you just copy paste code and not learn what's happening internally, you're just wasting your time. You're not learning anything, right? So you saw this code, great. You read someone else's code, but you also should go to function reference, read what does it say. Look at what it says. Okay, this is very important to understand. Okay, so what does it say? It says, okay, random values in a given shape. Okay, so what are the parameters? What are the parameters of this function, and what is the return value of this function? These are two important parts, right? So this function takes d0, d1 up to dn. All these are integers, and they're all are optional. So you can give a bunch of integers here, right? So what does it say? This is nothing but the dimensions of the returned array should all be positive. So all these numbers should be positive. If no argument is given, a single float value is returned, right? Just a scalar value is returned, because a single value is like a scalar value. It's not a vector or a matrix. What is a scalar? Just 23 is a scalar. What is a vector? A vector is like this. A vector is like an array, right? Again, the mathematical term for it. So this is called as a scalar, right? This is called as a vector or array. This is called as a matrix. This is what is called as a matrix or a 2D array, right? Then there is this, right? So then there is a 3D array. There is a 3D array which has depth also like this, right? So this is your 2D array, also called as matrix, right? So this is called a 3D array. 3D, 4D arrays, all of them mathematically they're called as tensors, right? Again, the library TensorFlow that Google open sourced is a tensor. It performs tensor operations. Again, those of you who know deep learning will appreciate the fact that deep learning is all about tensor operation, not matrix operations, right? So I'll use the same terminology. A scalar is just a single number. A vector is a 1D array. A matrix is a 2D array. A 3D array, 4D array, 5D arrays, all of those are tensors, right? So please read the documentation here carefully. Read this line by line. What does it output? It outputs an ND array, a NumPy ND array with this shape. This is the shape of the array, right? So you have to always understand what is the input parameters, what is the output that this function generates, and oftentimes in the reference you're also given simple snippets of code like this, right? So please don't just Google search and copy paste code. Very importantly, you should always understand the function reference. Okay. Again, if you want to read the function reference, you just have to Google np random rand reference. I get the link, I read it. Okay, sounds good. So, okay. So one common error that we often observe is, again, you should read what this 5,4 means, right? So this 5,4, this is the resultant array size or resultant ND array. What is this? This A1 is an ND array. It's a NumPy n-dimensional array, right? That's what it is. That's very important to remember, right? So this gives you 5 rows and 4 columns. So this is basically giving you a matrix with 5 rows, 1, 2, 3, 4, 5 and 4 columns. That's what it is giving you. Many people we have seen in code assignments that people actually write 4, 5. They swap rows and columns. This is a very common error. Please don't make this error. Now, a good habit is once you have generated this, always print it, because when you see that the data is as you expect, you are much more convinced. So what I often do typically is I often print the data. I often print the shape of the data, sometimes even the data type also. So if you print A1, this is what you get. What is it? It has 1, 2, 3, 4, 5 rows and 4 columns as we expect. Cool. Now I also want to print the shape of A1. So I just say print A1.shape and it results in 5,4. Now there is one error that I've seen a lot of people commit. One very simple error. Again, thankfully our team, which evaluates hundreds of assignments on daily basis, has gone through a huge list of errors and they've shared it, and I'm covering some of those errors here. We see a lot of students saying instead of print A1.shape, A1 is an ND array. Remember what it is. Always remember what is the data type. A1 is an ND array. A1 is an ND array. Let's not forget that, right? So when you say a1.shape, okay, when you say a1.shape, this thing printed this appropriately. A very common error is they actually put the parenthesis here, calling the shape function, which is there, which is a shape function under ND array. Some people call this. The moment you execute that, what happens? Look at this. The moment you execute this, it gives you an error. What error does it give? It gives you a type error. It says tuple object is not callable. Now, how do you understand an error like this? Look at this. It says tuple object is not callable. What do you call? You call functions. Remember the terminology. You typically, again, thankfully, Python gives very, very readable error messages. You should look at programming languages like C. It's much, much harder to understand and interpret the error messages. Thankfully, Python is terrific. See, it says tuple object is not callable. It says you can't call this function. That's what it's saying. Why does it say tuple here? Let's understand that in a little while, right? Why does it say tuple, right? That's very important, right? Why does it say tuple, right? First and foremost, the moment you read this, every error message, please read it. It says tuple object is not callable, which means you can't call this function. Number one, which means there is no function like shape. There is no function called shape. So what do you do? Okay, which means this is an ND array. There is nothing called shape function inside it. Now, how do I get shape? One option is to just Google search, just try 4 or 5 things, brute force, and you'll get a solution. But a better thing always is to go through the documentation. Let me go through the documentation here. Okay. So, okay, before we go there, again, I'll tell you how to fix this bug in a little while by going through the documentation. Again, I started programming, as I told you, from 1999 onwards, right? Those were the days when Google search was in its infancy. We did not have proper internet connection to Google search. Google existed in 1999, right? But it was not as powerful and as good as it is today, number one. Number two, we didn't have internet connections. So what we would do, when I remember I learned C or C++ in 99-2000 period. So you have the whole C++ reference book, right? So for every major class, object, data type, function, keywords, you have the reference. So we used to go through this reference and understand why things are not working. Unfortunately, people stopped, especially people who started programming much later, have stopped doing it. Right? They just Google search, they get 4 or 5 links, they just copy paste it and they're done. Sorry, that's not how you become a good programmer. You should be extremely comfortable reading references and becoming a better programmer that way. Right? Please understand that. Number one. Okay. So now if I want, okay, so I'll tell you why there is tuple here and why is it not callable. I'll just come to that in a little while. But equally importantly, I hope the live is all okay. There is no issue with the live session. Somebody says, can we get IPython notebook? Yes, you will get it by the end of this live session. I'll share it. I'll share it in the, just under this, both in the description and in the first comment section. Okay, I'll share it. So this is the first thing. The second thing, if I again, as I told you, what I often do is whenever I have a variable which I'm creating like this, I print it to visualize this. I also want to see the shape of it. I also want to see the data type. So we all remember the type function, the type, right? We learned this type when we learned basics of Python. So we have seen people do print a1.type. Then what does it say? Look at this. Again, it gives an error. It's a common error that we have seen people commit. Again, I'm covering some very basic errors because this is the first session, right? So a1.type. So what does it say? There is an attribute error. The numpy.nd array object has no attribute called type. It has no attribute called type, right? So this is the error. This is the error message. I'll again explain you how to read this error message and this error message by just explaining you the basics of a class, object, some basic stuff. I'll just explain you so that this is much more interpretable. I'll revisit this error and this error in a couple of minutes. But the right way to do it is actually to say print type of A1. What does it say? Now it says A1 is a numpy.nd array. Now very importantly, when you get errors like this, that this shape is not callable, the type there is no attribute called type, first thing you should do is read through the attributes and methods of the numpy.nd array class. Now, some of you may not be comfortable with what is a class, what is an object and all of that. Let me give you a simple analogy, right? Suppose if you're creating a integer variable, right? Suppose you're creating a variable. Let's say you say x equals to 10. So what are you doing now? What are you doing now in Python, right? If you do this, what are you doing now? You're creating a variable. You're creating a variable x. This is a variable name, right? This is the value of the variable, right? And this variable, of course, you can also say int and all that. Then this will be integer. Of course, you can also create float, string, all of those things. So a class is basically a concept which came from software engineering, right? So if you look at programming languages like C, which is a very popular programming language, C is what is used as the core programming language, which is used for some of the most important systems in computer science, like the Unix kernel, the Unix, the Macintosh kernel, the Linux kernel, all of them are built in C. C does not have classes. There is no concept of classes in C. Okay, C is one of the great programming languages. Then after a few years, again, remember, C has no classes, but you can do everything in C that you can do in other programming languages, mostly. Most of them you can do it. So then people said, then they came up with this concept of a class. Okay. Again, this came from software engineering, because people, as they were writing more and more complex software, I mean, just imagine writing something like an operating system or something like a database engine is not a trivial task. So as people started writing more and more complex software, software engineers came up with the concept of a new concept called as class, and concepts called as object-oriented programming and object-oriented design. These are concepts from software engineering, right? Now, for us, of course, if you know object-oriented programming, object-oriented design, that's great. But even if you don't know this, it's okay, because I'll give you a very basic 10-minute overview of this, with which we can start understanding the basics. And as we progress, if you need more concepts, we'll cover more concepts. As I told you at the beginning, we will cover more topics as we need. Okay. So in our case, numpy.nd array, okay, numpy.nd array is actually a class, right? So you can think of a class, as an analogy, because this is a non-oops concepts. These are non-oops concepts, right? So I'll try to give you a comparison from non-oops concepts to oops concepts, so that it becomes much more easy for you to connect the dots. Again, this is just an analogy. This is not an equivalence. What I mean by that is, what I'm giving you is a rule book through which you can easily understand what's happening. Just like the way this variable is of data type integer, right? Suppose if I look at our data, look at our program, right? So what does that program do? So let's look at the function documentation, right? So as soon as I ran this, my np.random.rand, okay, if you go to the function reference, what does it return? It returns an nd array. Look at the function reference. It says it takes these integers, non-negative integers as parameters, or sorry, it takes only positive integers, not non-negative. It takes positive integers as inputs, because it says all of them should be positive, right? And it outputs an nd array. Which means what is happening in this line is, this function is returning a variable of type this class. So it is returning a variable of type numpy.nd array. Just like the way we have the data type integer here. Look at this. We have the data type integer here, and x is a variable of data type integer. Numpy.nd class, nd array is a class, right? Now A1 here, A1 in our example, A1 is a variable of type of this class, variable of this class. A variable of this class is also called as an object of this class in object-oriented programming. Again, the whole name of object-oriented programming came into existence because this is all about objects. This is all about classes and objects. You can think of a class like a data type, right? You can think of an object like a variable of the data type. Now, when you have a class has two important things defined on it, right? A class has, unlike, look at this, on a variable, you can apply a bunch of operators. You can apply a bunch of operators on integers. You can also apply a bunch of functions on integers, right? So here is where things start differing. Given a class, again, there is so much to cover. Object-oriented programming is like a whole semester course at undergraduate level computer science. I'm trying to simplify it for you here, right? So, okay. So just like the way you have, within a class, there are basically two parts. There is something called as attributes, right? So there is something called as attributes and methods, right? So there are two parts within a class. Attributes are basically, suppose you have a class. Within a class, think of a class as a holder which holds multiple values. For example, suppose one simple example is I can create a class called a student. Again, this is a very simple, I can create a class called a student. This student, all the information I want to store about a student, it could be his roll number, could be his name, right? It could be his, let's say, marks, all of these. So what I'll create is all these are attributes of this class student, right? On this student, I also want, so all these are called as attributes of this student, right? Again, the roll number could be integer, name could be string, marks could be float, all of that, right? So you can think of a class as a holding, as a collection. You can, again, I'm simplifying it a lot here. You can think of a class as a group of or set of related attributes corresponding to this class and a bunch of functions or methods. Methods is just a different name for functions, right? For example, on this student, so suppose I want to have a bunch of methods, right? So let's assume on this student, I want to, let's say, I want to change name. Suppose there is, I could have a function called change name. So on this student, I can call this function change name. Change name is a function which could have some parameter. Now I can say for the class student, I want to create a variable called S1. This is an object, remember. This is a class. This is a class. You can think of class as a data type, right? You can think of class as a data type, right? And it contains all of these attributes and all of these methods that you can execute on this data type. And given an object, right? So suppose you have S1 as an object, right? S1.roll number. So S1 is one student's information, right? I can store information about the roll number of a student in S1 of one student. Similarly, S2.name. So similarly S1.name, similarly S1.marks. All this is information related to one student. Similarly, I can create another object S2 for a different student. Again, these concepts came into existence to simplify software engineering. Again, if you see non-object oriented languages like C, the amount of code and the complexity of code that you have to write is significantly more than programming languages like C++, Java, Python, all these languages. These languages are much more, again, today we build much more software using these because it's easier to build, especially given that sometimes hundreds of developers jointly develop code, right? So that is the crux of it, right? Again, I've simplified it because I wanted to explain you these two error messages. Okay, so we know, see now you know what is an object, right? So I wanted to explain this, right? So what does it say? It says, okay, so let's look at these two. I want to explain these two error messages in little more detail. So what does it say? It says a1.type, right? So what error message does it say? numpy.ndArray object, because a1 is an object of type numpy.ndArray. It has no attribute called type. I'm trying to access this attribute here. It has no attribute. That's what it means, right? Now let's see what attributes are there. If you want to figure out what attributes are there, what methods are there, let's try to figure it out. Next, when I call this, when I write this, it says this is not callable. What does that mean? This means there is no function called shape. But then how do I get the shape of it? Right, look at this. What was the correct syntax here? What was the correct syntax here? Just a1.shape is the correct syntax. right? So what does this imply now? This implies that when I do, so A1, which is an ND array, has an attribute called shape. It has an attribute called shape with which I can get this data. It does not have a method called shape. Remember, whenever I say a method, what I mean is a function. Whenever I say an attribute, it means a variable of a specific data type within a class. Okay, so let's go and read the function documentation, right? So let's go here. Okay, so you can just Google search numpy.ndarray. The first link that you get is obviously the function reference. Let's go and read the function difference. Please remember, there is nothing that beats the skill of reading function differences. Okay, so it says it's a class numpy.ndarray. Okay, so there are a bunch of things. Okay, so let's go down. Okay, so look at this. It says attributes. These are all the attributes that are there. Look at this. Look at all the attributes that are there which we can access. Right? Shape is an attribute. And what does shape give? Shape gives you a tuple of integers. Look at this. So I'm in the numpy.nd array. Numpy.nd array has a bunch of attributes. Within the attributes, you will see the shape. When I use the shape, what should I get? I should get a tuple of integers. I don't see the, look at this. If you go through all these attributes, you do not see, you do not see the attribute, what was that? You do not see that attribute type. Look at this. There is no type here, right? There is t, data, flags, int, real size, n bytes, ndim, shape, blah, blah, blah. Right? So there is no type. So this error message is simply saying that A1, which is of type numpy.nd array, it has no attribute called type. That's what it means, right? Number one. Number two, let's look at this. Now let's go back and understand this in more depth. So what does this error message say? It says this is not callable, which means there is no function like this. And it says the tuple object is not callable. Why does it say this? Because the moment it runs this, what does it get? It gets A1, the moment it runs this, A1.shape. It is running this from here. It's running A1.shape. What does A1.shape return? A1.shape returns a tuple, it returns a tuple of integers, right? We printed A1.shape, right? We got a tuple 5 cross 4 here, 5 comma 4. Now on the tuple, look at this, now what do you have? What does it return? A1.shape returns a tuple object, right? Remember, A1.shape returns a tuple object. Now the tuple object is not callable. You can't call a tuple object. A tuple object is a tuple. It's not a function. You can't call it. That's why the error message here is tuple object is not callable. I hope this is clear. Again, understanding error messages, understanding documentation is extremely important. I know I'm spending too much time on just 2 error messages, but these are skills that will stay with you for life. Trust me. Okay. I've learned programming like this. We have seen a lot of students learn programming like this. Okay. So now this is clear. Okay. I know I have spent too much time on a simple concept, but it's important to understand this concept in depth. That's why I'm doing this dive deep code walkthroughs. I'm giving these common errors and all of that. Okay. So now what do we have? Okay. So what did we do? Finally, we learned to read some documentation. We also got A1, which is a NumPy array of size 5 rows and 4 columns. So again, let's not forget our big problem. We want to create 2 randomly generated NumPy matrices and add them. So one, we created A1. Now similarly, I can create A2 also. Nothing stops me. So create random matrix A2. Simple. np.random.rand 5 comma 4. Remember, very importantly, I should create the matrix of the same size here. Because can you add 2 matrices of different sizes? Imagine if A1 is 5 cross 4 and A2 is 3 cross 2. Can you add these 2 matrices? It's not a valid addition in mathematics. In matrix algebra, this is not valid. The length, the size of the matrix should be the same. If it is not, it will throw an error. I think I have that error somewhere. I'll show you that. Okay. Again, I always print my matrix just to be sure. Now, another very common thing. So what do we have now? We have both the matrices. Now we want to add them using loops. Okay. We want to add them using loops. How do I do that? Look at this. I have a 5 cross 4 matrix here. 1, 2, 3, 4. Always draw diagrams. Plus 5 cross 4. 1, 2, 3. Okay, I think I should erase this. This is 5 cross 4, right? Sorry. 1, 2, 3, 4, 5. Okay. Similarly, 1, 2, 3, 4, 5, 3, 4. Okay. 5. Okay. Now, how does addition work? You take this element, you add with this element, that becomes the result in, so let's assume B equals to A1 plus A2. What is the logic of addition? First, let's understand the logic of simple addition in matrices, right? So, the first row, first column, first row, first column, you add both of these and that becomes the first row, first column in B, right? Now, what is the typical logic here? The ith row, jth column in B should be A1 ith row, jth column plus A2 ith row, jth column. This is the concept, right? This is a mathematical way of writing the same thing, where I is a bunch of numbers corresponding to the rows, j is a bunch of numbers corresponding to the rows. So what does this say? This says that the value in the ijth cell of B is the sum of values in the ijth cell of A1 plus the ijth cell of A2. Very simple, right? This is the logic. This is what we all have been taught probably in a 11th, 10th class. This is how you add two matrices, right? Now we just have to put it in code. Now one important thing that you have to remember here is to do this, again, the logic is simple, we got the logic. Now how do you convert logic to code? That's an extremely important skill. Now first and foremost, the moment you see this, you should realize that you should be able to access ith row, jth column in a given ND array. So you have an ND array and you want to access the cell which is in ith row, jth column. How do you access it now? Right? Simple question. If you know how to access, great. Because if you don't know how to do that, you can't solve this problem. Right? So the second sub problem is figuring out how to access the ijth cell in each element. Just Google search for it, accessing ijth element in an ND array. Just Google search for it. This is the link that you'll get it. Again, this is from the official documentation. Sorry. I think I did a mistake. Sorry. So I think this is from the official documentation. So, okay, the n-dimensional array. Okay, if you just look at this, indexing arrays, right? So it says, okay, array indexing, blah, blah, blah. So just, okay, so there is ton of stuff in this, right? Just keep looking at it, right? Just keep going through it. Because thankfully Python documentation is so damn good that it's extremely readable. Okay, there is a ton of this. Okay, we didn't find any code here. That's okay. Let's see. Okay, the array can be indexed. So if you look at, again, whenever I read documentation, I also look for code snippets. Okay, what does this say? It says I can access the first row and the second column. Look at the element of x in the second row, third column, namely 6 is this. Oh, sorry. Shape is this, blah, blah, blah. Okay, I think, see, this is how, where is it? Constructing arrays, indexing arrays. Okay, ND array, indexing arrays. Okay, array indexing. Let's see array indexing. Okay, ND arrays can be indexed using standard Python, this syntax, right? So all you have to do here is x, blah, blah, blah. Now let's try it. See, there is something given here. Unfortunately, not much of code, but let's go back to our thing and try a few things. Let's see what goes wrong. Okay, so I saw this. So look at this. By reading this, what does it say? X. And this, it says, okay, I want to say which row, which column I want to access. That's what this syntax tells me. Again, I could be lost, but let me start trying it. Okay, if I want to access, let's take A1. We have printed A1 earlier, right? We have printed A1 earlier. So we know which row, which column, what element is there. So what I'll do now is, I'll just say, print A1 2, 3. This should give me second row, third column in A1. See, when I execute this, I get some value, but I want to be really sure. So let's go to A1, second row, third column. Okay, what is the value printed here? 656852. 1 second. 65. I hope this is printed correctly. 1 second. When I print this, A1 2, 3, it prints 6568528. Is that value, is it A1 or A2? 1 second, let me just print A2 because we have A2 right here, right? So let's just run it. Okay, so what is it giving me? It is giving me 1012 blah blah blah. Okay, so what is it giving me? Is it giving me second row, third column or third row, second column? Let's see that carefully, right? So where is this 1 0 1 2 8 6 blah blah blah? Where is it? Is it in second row, third column? No, it's not in second row, third column. Right? It's not in second row, third column. But where is it? Is it in third row? A1. 1 second. Let me just see. 1.2. Okay, so this is all right. This is giving me A2. This is my first row, second row, third row, fourth row, fifth row. Okay, the rows and columns are all clear. Okay, let's do this. Oh, so the indexing, sorry. The indexing is 0, 0 indexing, right? So anyway, so let's start this. I'm counting incorrectly. So 0, 0. So 0th row, because all the array indexing is 0, 0 indexing, right? I start counting from 1. Sorry, my bad, right? So let's take 1, 0. Always try a few things. This is first row. This is, what is this? 1 basically means second row. 0th row, first row, and first column. Yes. Okay, so let's go 2, 3 now. Okay, so what is 2, 3? Let's write it down here. It's better to write it down. This is the 0th row, first row, second row, third row, fourth row, 0th column, first column, second column, third column. Right? Because in Python, just like in C programming, the indices start from 0. So 2, 3. This is 2, this is 3. Perfect. This is the value that is shown here. So it's working. So I can access ith row, jth column using this syntax. It's always important to be careful. It's good to experiment, right? A very common error that we see people do is this. Okay, look at this. Instead of actually placing this in square parenthesis, we have seen people just pass it like this, like a function. See, what is happening here? This is as if you're calling a function with 2, 3. Right? This is not, again, this is the indexing. This is how you index. How did we know this is how we index? Because we went to the documentation. Right? Look at this. It says, this is how I have to index. Again, there is one more very important aspect, which is errors between Python 2 and Python 3. As you can see, I'm using Python 3 here. There are some changes between Python 2, Python 3. Sometimes you have to search for Python 3 in your search also. Now, if you execute it like this, look at this. If you execute it like this, what happens? You get an error. Now, what is the error? Read the error very carefully. Thankfully, Python gives beautifully readable errors, unlike C or C++. It says numpy.nd object, because this is a numpy.nd object, is not callable. You can't call this function. That's what it says. So, such an easy thing. By reading this error, you can quickly figure out that this is not a function. There should be some other way of accessing it. Right? It's that simple a concept. Now, if you look at this documentation, look at this. If you look at this documentation, it says in Python, x within square brackets, I can give a tuple. Remember, everything in Python which I write like this is a tuple. If I write 2, 3, this is a tuple in Python. Right? So it clearly says that I can write it like this or I can write it like this. Both are equivalent. So let's also try that. So whenever you're learning a programming language early on, this is a good thing to try. Okay. So look at this. Here I've just not put the tuple. I've just put square braces. Now I'll also put this. And if I execute it, what happens? It works. It works. So the error here is you're calling this A1, which is an ND array object, is not callable. If you just put like this, it would have worked, as we have just seen right now. That's again, always see what should you give here. You can give a tuple. We have given a tuple here, or you can give a comma separated integers. Both of them are equivalent. Look at this. It clearly says that. You can either give a tuple here, or you can give a comma separated list of integers. This is a very common mistake that we have seen people commit. We have seen students send us an email for this. Okay, of course, we resolve it. But then it's such an easy thing for them to resolve and learn. Right? Once you learn how to fix it, you will not forget it for your life. Okay, so now we have learned how to access this, right? So let's go back to our original task. Where is the task? Okay, this is what we wanted to solve. Now we know how to get ith row, jth column in A1. We know how to get the item in ith row, jth column. Now, okay, let's just use the default operator, right? I can also add two ND arrays using the plus operator, right? I can say B equals to A1 plus A2 and print this. This is a very simple way of doing it, right? Very, very simple way of doing it. But I don't want to do it using the plus operator. I want to do it using for loops because I want you to learn for loops. It's a very important skill to be able to write loops because that's a very, very common construct in most programming. So for that, look at this. I have A1, I have A1, I have A2, right? A1 I comma j plus A2 I comma j equals to B I comma j. But what should I and j be? This is what all are the valid rows. Look at this. A1 has a size of 5 comma 4 or shape. Let's not call it size. Let's call it shape, right? A2 also has the shape 5 comma 4, which means this I is 0, 1, 2, 3, 4. This j is 0, 1, 2, 3 because these are all the columns that you have. These are all the rows that you have. By just looking at this fact, this should immediately strike you that you have to use loops, right? So what is this? Bij equals to A1ij plus A2ij for all I where I is 0, 1, 2, 3, 4 for all j 0, 1, 2, 3. That's the idea. So the next sub problem that we have to figure out is how do I get the shape of A1? We already learned that. Look at this. What does A1 dot shape give me earlier? We saw this documentation, right? What does A1 dot shape give me? If you're not sure of it, just go back to documentation. What does the shape function return? It returns a tuple of integers. Remember, always remember what it returns. So what do I do now? It returns a tuple of integers. So what can I do here? I can do a very simple thing. I can just say A1 dot shape and assign this to a tuple. This is a tuple, right? Because it's in simple braces, R and C. So what is R now? R will take the value of 5, C will take the value of 4, right? Because this is a tuple, right? Again, I always write print messages to make sure that everything is working. So when I print it, I know that R is 5, C is 4. Now we have to write our for loops, right? Very simple code. This is not rocket science. This is like very basic stuff. Now, how should we do it? First, look at this. We have our matrices like this, right? So 5 rows and 4 columns. Okay. First, let's go to the 0th row. First, let's go through the 0th row. Within the 0th row, let's go to 0th column, first column, second column, third column. Then first let's finish these 4, right? Then we'll go to the second row in the or the first row, if you want to call it the first row, 0th column, first column, second column, third column, and so on and so forth. That you can write using a very simple nested for loop. For I equals to range R. Now R is 5. What does range R give me? Range R gives you 0, 1, 2, 3, 4. We've discussed about range. I'm assuming you know the range function. If you're not sure, just Google for it. It'll go and read the documentation. Then you have range C. Range C gives you 0, 1, 2, 3. So now what is happening? Look at this. The I values, initially I will be 0, right? Initially I will be 0. Within this, I have this within the loop. So J will be 0, 1, 2, 3. So what am I doing? Bij is A1ij plus A2ij. This is how I access the elements. This is how I access the first element. This is how I access the ijth element. So by the time this loop runs, my B00, B01, B02 and B03 are done. Next, I continue on the loop, right? Now, what will be the second value here? This will be 1. Again, this will be 0, 1, 2, 3. By the time I finish this simple nested for loop. By the time I finish this, what do I get? I get my B. I can print B. And what do I do just to verify? I verify that this B is same as this B. I just visually compare both of them. They are the same. Now, there is one optimization that you can do on top of this. I hope this is clear. Again, I focused a lot on how to read bugs, how to fix them. This code is straightforward, right? This is extremely straightforward, right? So the next thing is, again, I think one of our assignment problems is to multiply two matrices using for loops, which is slightly more complicated than this, but it's also fairly easy. If you know the logic, if you know how to convert the logic to for loops, as I just showed you, right? I've shown you this diagram. This is how you convert the logic to for loops. That's it, you're done. It's actually fairly straightforward. Next, there is one optimization that you can do here. Look at this. the B matrix, right? You have not allocated any memory space for the B matrix before this loop. Look at this, before this loop started. So what's happening here is, there is more, again, this is an code optimization. Again, this is a topic in compiler design, etc. But I just wanted to teach you a good programming habit in general, right? So one thing that you can do here is, see, what are you doing here? You have not assigned any memory space for B. So what's happening is, as this loop runs, the size of B is changing because more elements are being created. Look at this. Initially, you have only B0, 1, right? So B00, B01, B02, right? So on and so forth. Then you went and said, okay, B also has first row, right? Then you, as the loop progresses, this is creating more space in the memory. Again, remember that everything has to be stored in the memory, in your RAM or main memory, as it is often referred to as in computer science, right? So what is happening here is, the size of B is changing within the loop. And if the size has to change in every loop, right, this can create special problems if B is a large matrix. It can create problems. This can be, again, for this small sized problem, it may not be very complex, but a good programming habit is to pre-allocate matrix B. So one thing that you should do is just create matrix B with all zeros first. We'll see the syntax. First create B with zeros of size 5 cross 4 and then fill it up here. That way, as soon as this line runs, there is memory allocated for B within your RAM or main memory, and then each of these lines is changing each of these cells within B, right? In the previous model, if you did not pre-allocate B, the size of B is changing, the shape and size of B is changing in each iteration, which can be more cumbersome because, again, that goes into compiler design, memory reallocation, all those challenges, right? So a good practice is to pre-allocate B. It's a good habit, good programming habit. Okay, so in our case, suppose if I want to allocate zeros, okay, one thing that you may have seen in our code snippets is B equals to NP zeros 5, 4. You get an error. What is the error now? Okay, look at the error. This is very, very interesting error. So the moment you write this function, you get an error. What does the error say? Data type not understood. What data type is not understood? I'm saying create zeros, right? The B I know has to be an ND array. That is very clear because I'm using Numpy here. What data type is not understood here? This is a very common mistake, by the way. Data type is not understood. So first thing you should do here is, let's go to np.zeros and read the documentation. Okay, so just Google search for np.zeros, you'll get this link. Let's go and read the documentation. Again, reading the documentation is the way you learn. Now this is very important. So how does np.zeros work? Look at this. There are many ways of doing it. So look at the documentation. What are the parameters here? What are the parameters? The first parameter is called the shape. The shape can be an integer or a tuple of integers. It can't be just a sequence of integers. It has to be a tuple of integers, right? If I want, again, I can say what data type I want to generate, but it is optional. The default value is float. This is the default parameter. Order, this is also optional, so let's not bother about it. So what is the mistake that we have done? We should be able to understand this. Look at this. The shape parameter can be a single integer, or if it is multiple integers, it has to be a tuple. That's the data type error we are getting here. Look at this. That's the data type error we are getting here. The data type not understood because if it was only just one number, you can call it like this. If it is two numbers, you should always call it like this. Look at this. Instead of, see, I have to pass a parameter because it can either be a single integer or a tuple of integers, right? So what I have to pass here is a tuple. I created a tuple and I'm passing it as a parameter, shape parameter. Rest everything is optional parameters, right? So what have I done here? I have pre-allocated the space for B in my main memory with all zeros. This loop is same as what we have seen earlier. Very simple loop. Very, very simple loop, right? I hope this is clear. Again, I know I've spent almost 1 hour on this. but I wanted to go through the documentation, read the reference, help you understand how to fix these bugs. Okay. Number one. Okay. So next question for all of you. Okay. What is the time and space complexity of this? Okay. I'll go to the live chat window. Okay. So what is the time and space complexity of this? Can anybody suggest me in the chat window? What is the time and space complexity for this algorithm that we have written? Okay. I hope everybody saw the algorithm. It's just a simple nested for loop. What is the time complexity and what is the space complexity? Sorry, we are here. So is order of n square the space complexity or the time complexity? What is n here? You have to be very precise when you say order, whether it is time or space complexity. Please mention that also. Quadratic, okay, n square. All of you are talking about space complexity or time complexity. Please mention that. Order of n time complexity, big O of n square, big O, time complexity is n, time complexity. What about space complexity? Nobody is talking about space complexity. Can somebody tell me space complexity? Space complexity is n square, okay? 2 loops, so n square. Not always. I can show you 2 loop codes which are not n square. 2 loops does not always make it n square. Be careful. What about space? Nobody is talking about space, guys. Please tell me what is the space complexity. I'm looking for that. Time, most of you got it right. What about space? Okay, space, order of mn. Okay, order of mn. Okay, space is order of mn. There is a small caveat there. Okay, so let me explain this. So the time complexity is obviously order of rows comma columns. Because look at this. This is, you have R rows and C columns. Okay, it's as simple as that, right? It's just a 2 for loops. You're going through all the rows, all the columns. Again, just don't fall for it. I can write code with 2 for loops, which is not order of R into C. Again, if you assume that R equals to C equals to n, this is same as order of n square. Fair enough. What about space complexity? That's the tricky part. So this is trivial, rows comma columns. What about space? So when you compute space complexity, you should not compute the input space and the output space, right? Because you can't escape input and output. So for this system, A1 and A2 are input, right? This is the input to this matrix addition algorithm. B is the output. So you should not include input-output space complexities. Apart from A1, A2 and B, what other variables did we create? We created I, we created J, we created R and C. Just a constant number of variables. So the space complexity for this is actually order of 1, which means constant. It is not dependent on the number of rows and columns. Right? This is a small tricky, that's why I asked you space complexity specifically. It's a very simple concept. The space complexity is constant because you are not using any, see, that's what I told you, right? You should not count input space and output space because whatever algorithm you have, the input space is always needed, the output space is always needed. Apart from input and output, what additional space are you using? Only for a bunch of constant number of variables. That's it, right? Hence, because this is constant number of variables, it is order of 1, right? So that's a slight tricky part there. Now I want to give you a simple algorithm, simple extension. Intentionally, I kept it simple, okay? The exercise that I want you to try, again, this should not take you more than 10 minutes. I mean, you can write it in 10 minutes actually, okay? Add 2 randomly generated Numpy 3D matrices. Again, anything above 2D matrix is called as a tensor. 3D matrices, 4D matrices, all of them are called tensors. Again, add 2 randomly generated Numpy 3D matrices using loops. Again, it's fairly simple concept. B ith row, jth column, kth, ijk cell is a1 ijk plus a2 ijk. Simple concept, very simple. Now let's go to the next problem. Okay, again I'll keep telling you errors and mistakes, but I hope we can solve the second problem faster. Okay, so the second problem here is find if a given 2D point is inside or outside a circle. Right? This is the second problem. Think about it. It's a simple problem again. Again, this problem is very relevant to the context of machine learning, data science, etc. Because in machine learning and data science, you always work with lines, planes, hyperplanes, whether something is on this side of the hyperplane, this side of the hyperplane. You work with rectangles, hyperrectangles, hypercuboids, etc. You work with circles, spheres. Again, linear algebra is all about the study of these shapes, and these shapes are extremely critical to whole of machine learning and deep learning, right? So, okay. So given a 2D point, I'm giving a very simple example. Given a 2D point, find if it is inside or outside a circle. This is the question, open-ended question. So my first question here is, how do you represent a circle? To represent a circle, again, this is a 2D space. You can represent a circle by the center. The center has x coordinate and y coordinate, right? You can represent a circle using the center and a radius. So you can represent a circle using, the simplest representation of a circle is just using 3 numbers in a 2D space. I'm only talking about a 2D space. In a 3D space, the equivalent is a sphere. In 4D, 5D, 10D, 100D, it's a hypersphere. We discussed that in our linear algebra videos in our course. I think some of them are also free for everyone to watch. Okay, so you can represent a circle using the center and the radius. Now given this, if I have a point, so let's assume there is a point. Let's call the point as P. How do you represent a point in 2D space? The x coordinate and the y coordinate, right? Suppose if there is a point here, okay, which is Px comma Py. Suppose that there is a point here. You just need 2 coordinates, x coordinate and y coordinate. Now, when do you say that this point is inside the circle? When do you say this point is outside the circle? Very simple. This is almost like high school mathematics. I intentionally gave simple problem here. Again, I'm starting with simple problems, but I'll go to more complex ones. We'll do permutations, combinations, all of that by the end of this. I think we'll run out of time. But anyway, we are not short on time thanks to the lockdown or whatever. We'll continue wherever I will not rush. I want to go slow and steady so that everybody is with me. Okay, suppose if the point is here, how do you determine this? Very simple question. So let me see what you guys think of in the chat window. Okay, somebody says find the distance of a point from center. Okay, then what should I do? This is a very simple question. Okay, I find the distance of the point from x square plus y square is less than r square. No. This won't work, no? Why would that work? Come on, let me construct a counter example for you. No, that won't work. Come on, guys, that won't work. Let me show you. Suppose if I have a circle like this, let's assume this is 0, 0. Let me just construct an example. So you said px square plus py square is less than equal to r square. This is what you said, no? But not necessarily always. So let's assume this is, let's say, minus 100, 100, minus 100, minus 100. Let's assume the radius is 10. And I have a point here, right? This point is, let's say, some minus values, right? This is not true. This, again, we can construct an example and show that that's not true. Some more detail. Distance between the 2 points. What 2 points? Somebody is saying distance between the point is more than the radius. Distance from which point to what point? Just be very precise in your answer, folks, please. Somebody wrote it very well. Good. So let me show this. Square root of px minus xc square, py minus cy square is less than r. Cool. This is good. This is the right way. Very good. So the idea is simple. Okay. The idea is very, very simple. Suppose if this is my circle, right? So this is my center, cx comma cy. This is my radius. So if this is my point px comma py, I just have to compute this distance. If this distance, let's call it D, if this distance D is less than R, then it is inside. If this distance is equal to R, then this is on. This is inside, right? If this distance is greater than R, it is outside. Simple. So all I have to compute here is this distance. What is this distance? Like, this is like simple stuff that we learned. Distance between 2 points. Cx minus px squared plus cy minus py squared, the square root. That's all. This is your D. So all you have to do now is compute the D and do a simple if else. That's all there is, right? I'll tell you typical code errors that happen. Very simple problem. This is extremely simple, right? I mean, extremely simple. But I'll show you code errors that people, that very common to commit. Very common errors to commit, right? Good. So first and foremost, okay. So input circle parameters. What is our first task? So we got the logic. Let's translate the logic to code. First task is to input Cx, Cy, R. Second is to compute input Px, Py from the user. Then compute the distance. Then if else of this. That's all. There are 4 parts to it. 4 subparts. Very simple problem. Now let's go here. This is where the fun starts. Okay. The coding nightmare sometimes starts. So imagine if you forgot how to input multiple inputs in a single line. You can just Google search for it. Input multiple values Python. You get a nice link from Geeks for Geeks. You saw that code. You pasted it here. So what did you say? You said print enter Cx, Cy, R. You are using raw input. You can use input or raw input. Okay, there are 2 functions, right? Again, if you go again, I just Google search for it. I got this link. Whatever was there, I just pasted it here. Dot split. But as usual, what does after I split? This is the code that I got from here. I didn't understand what it's doing, but I know that split does a split of a string. Given a string, it splits by the delimiter. This function I know a little about, right? First, again, whenever you see code from anywhere, please understand what's happening. The split basically takes a string and splits it by a delimiter like a space. We know that. You can Google. Again, we've discussed this in the course videos. What does raw input do? Again, if you're not sure, always Google search and read the documentation. So just write Python 3 raw input. Okay, so Python 3 raw input. Okay, there is some. Okay, can we get the documentation? I think that's better. Reference. Python raw input. Okay. Okay, this function is removed from Python 3. I thought I was using Python 3. I clearly mentioned that I want to use Python 3. Is it using Python 3 or Python 2 still? Or maybe this is still using Python 2. I hope, again, I'll have to cross check that. My default is Python 2, but I wanted to write in Python 3. Again, there could be some errors because of the versioning in Python. Just be careful. But anyway, let's read raw input. Let's see what does it do. Okay, block this. Python input. Okay, so this is Python input, Python raw input, right? So actually Python raw input function is removed from Python 3 version, okay, but it exists in Python 2. Actually, it's the same functionality as Python input. Okay, cool. Okay, we know what it does. It seems it's removed from Python 3, which means most likely I'm running this in Python 2. Okay, even though I have Python 3 set here, I'll have to cross check my system settings. I'll do that in by the next live session, right? Anyway, raw input works very similar to input. We have seen the input function in our course videos. We know what it is, right? Okay. Now, the moment I do this, I get an error. Let's read what the error is. Okay, when I try to run it, okay, this is where things go crazy. I try to run it. Okay, raw input dot split. Let me run it actually for you. Okay, so let's assume I type 1.0, 1.0, 5.0. Okay, I run it. Enter. Oh, so it's taking it. So no problem, no error here. Cool. It's taking the values. So no issue for me. Cool. This is good. So I think this is just the Python version. I think I was earlier running in Python 3. It was not working. Python 2 now, probably it just, I restarted my IPython notebook just before the live session. I think this is some issue. Fine, it's working. Cool. So what is happening here? Oh, but there's a problem. When I print Cx, Cy, R, look at this. This is very interesting. Okay, so most likely I'm running Python 2 if I'm not wrong. Again, we can check that. Okay, actually, let's just check that. Okay, so I don't remember the function. Python version print. Okay, get the Python version. How do I just say? Blah, 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 print sys version, blah, blah, blah. Okay, that's good. That's it. Okay, import sys, print sys version. Okay, let me just, okay, sys is basically all the system commands. Let me just try what's happening. Insert cell above. I want to see what is actually happening. Oh, it's running 2.7. Yes, that's the problem. Okay, I think, okay, sorry for the mistake. I'm still running Python 2.7, not Python 3. So from the next live session, I'll ensure it's all Python 3 code. Okay, sorry for that. Yeah, but that's okay. So because I got an error last time I ran, I think some mistake in my IPython notebook setup, but that's okay. So I ran this. What is the error that I'm getting? Oh, so I actually got some error in Python 3, then I went to something else. I tried a couple of things, okay? Okay, but let's keep one thing in mind. So what it is doing, it's actually reading the whole input as a string, and it is splitting the string. Look at this. What did I input here? Let's run this again. Okay, so 1.0, 1.0, 5.0. Okay, this is the input that I've given. So whatever I've given, it is taking it as a string, and it is then splitting it. Well, how does the split function work? Split function basically splits by delimiter. So I gave 1.0 space 2.0 space 5.0. So it used this as a delimiter. It made Cx equals to 1.0, Cy equals to 2.0, radius equals to 5.0, but it is not treating them as floats. It is treating them as strings. Look at this. It is treating them as strings because the split function returns strings. Again, you can verify that. The split function Python reference. Okay, so okay, W3 schools, blah, blah, blah. Okay, I prefer the official documentation. Split, okay, string.split. Okay, the string.split, it uses a default separator, blah, 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 blah. Return a list of words in a string. It returns the list of words. So it's going to return a list of strings because a word is a string, right? So what I have now are basically strings, not floats. That's something that I have to be careful about. Again, while I was trying a little earlier with Python 3, not with Python 2, I faced a slightly different issue. This was not working. It gave me an error because raw input was not available in Python 3, right? So it was not available. So I had to go back to using simple input. So again, please note that this will work in Python 2, but not in Python 3. In Python 3, raw input is not available. Unfortunately, I'm running in Python 2.7 as we just saw right now. Always be careful with the version because there are some major changes, like raw input doesn't work, right? So there are a bunch of important differences between Python 2 and 3. Just be careful, just Google search carefully. So then I Google searched for the same line. I got a bunch of tutorials. I went through them. Always try multiple approaches. But this is clear. Raw input, what I saw in this Geeks for Geeks article was not working earlier because it's not Python 3. In Python 3, we know that raw input doesn't exist, so I just used input. Now, when I used input in Python 3, I got this error. Now, I said, what is wrong with this? Something is wrong with this. Okay. So initially I got some error. Then I said, okay, is there some error somewhere here? I think I jumped between Python 2, Python 3, all of that stuff, right? So finally, I got it to work using raw input itself, which is available in Python 2, but not in Python 3. Okay, the catch here is after I print this, remember, after I print CXCYR, the first thing that I realize is that these are actually floats. These are actually strings. But I did not care about it. I just said, I didn't notice it. I didn't notice these. It's very common mistake that people do, the data type mistakes. I said, okay, let's go with it. I thought I forgot to notice this carefully, right? I thought they were floats, right? Cool. Second thing, let's input our point x, point y. We input it again, raw input, Python 2 works well. If you notice carefully, these are also strings, not floats. Then I simply wrote this logic. I simply said, what is my d? My distance is cx minus px squared. This double star basically means power of. Cy minus py squared. This is my distance. Of course, I should also put a square root, which I did not put. There is a mistake there. I know it. Just bear with me. Then I said print D. If D is less than this, P in C, point in circle, otherwise point not in circle. But before it even went anywhere, it gave me an error. It said unsupported operand types for strings. So it said I can't see operand types for subtraction. You can't do subtraction on strings. That's what it means. It is an unsupported operands. So the operator here is minus. The operands are cx and px. I can't use string operands on a minus operator. I can't do that. That's what it's so cleanly said. Then I realized, okay, there is a problem here. Then again, very common mistake. People forget to put the under root here. Okay, I wanted to point that out. So I corrected that. So I said, okay, cx, cy, r, px, py, let's convert all of them to float. I'm typecasting them to float. Then I import math because square root is there in math. I compute my distance. I print it. I say if d is less than r, p is in circle, else p is not in circle. I computed the distance. Look at this. What are the values that I entered? 0, 0, 1. I think that's, sorry, the values that I entered are, my circle is 0, 0 as the center and the radius is 5 and my point is 1, 1. Right? My point is 1, 1. If the point is 1, 1, the distance from 0, 0 is square root 2 and this is square root 2. So everything is working well. My P is in C. Cool. Very simple. Again, it is the reason I picked this problem is because of the common errors in how do you input into version 2 and version 3. And again, this is a very simple problem. This is actually like 5 minutes problem, right? But it's impossible. It's important to, the major takeaway from this example is that the logic is simple, but you can get caught up in these raw input type of bugs. Number one, right? And typecasting is an important thing if you are performing mathematical operations. Just please be careful you don't miss that. I have an exercise problem corresponding to this. The exercise problem here is find if a point is inside or outside a rectangle. That's the problem. I hope it is clear. So you're given a rectangle and you have to determine, you're given a rectangle R and given a point P, you have to determine whether P is an R or not. Again, this is very, very important for machine learning and data science because rectangle in 2D becomes a cuboid in 3D and it becomes a hypercuboid in higher dimensional spaces. And that is extremely important in the context of decision trees, etc. Right? Can you determine whether a point is within a rectangle? Now the big question here is, you know how to represent a point using its x coordinate and y coordinate. This is 2D space. We're only talking 2D space, guys. I'm not complicating it for you. We'll do that when you do linear algebra, I'll go to 3D, 4D, I'll go to hypercuboids and all of that. Now I wanted to keep it simple. My question to all of you is, how do you represent a rectangle? I want to hear your thoughts. Right? The question is clear, right? How do you represent a rectangle? Somebody said use eval for input. Yes. So what happens is the difference between raw input and input, if you read it, actually I placed that link here. I forgot to go through that. There is a very nice Stack Overflow link because I got this error when I was using Python 3. Okay. So I got this error. Okay. Let me also show you. So I got this error, right? A very good point. Thank you for reminding me. So I got this error. So what did I do? The moment I got this error, I couldn't understand it. In Python 3, when I ran this, I got this error. So I entered 0.0, 0.0, 5.0, input function, everything should work. It says syntax error, invalid syntax. I'm like, dude, this is simple. I mean, I don't find any bug in the syntax, right? These are these are the values that my input will split and give me. Cool. My input function has a string that I can call. This string will be shown here. This is simple. I'm calling split on it. This is a string split. Everything should work. It gave me invalid syntax error actually when I tried it with Python 3. Actually, I didn't understand it. To be honest with you, I was trying multiple things to show you multiple cases. And the moment I saw this, I was like, what is wrong here? I don't understand anything that is wrong here. Then I said, okay, let's Google search. Okay, I just Googled syntax error, invalid syntax on input function Python 3 string, because this gives me invalid syntax string, right? It's on string. So I used all the keywords. I said I'm using Python 3. This is on a string. The error is syntax error, invalid syntax. I Google searched for it. Stack Overflow anyway. That's the best place to find resolutions to bugs. So I saw this on Stack Overflow. Let me walk you through this. Okay, so someone else had a similar problem, blah, blah, blah. So this guy actually writes a very nice answer. Where is the answer here? Okay, so he says input is equal to eval of raw input. The error you saw was Python tried to evaluate this expression. Python was trying to evaluate this expression and it failed. Because this is not a valid expression in Python, right? 3 space 5 space 2 is not a valid expression, right? So input is equivalent to, this is a very nice answer. I love this answer, right? I forgot to mention this. So I got stuck. Python 2.7, Python 3, in all of that jhanjat and confusion, because I couldn't understand what the heck was happening here. Then I said, okay, let's go here. I Google searched for it. I got this. So the moment I read this, I understood, okay, whatever raw input is getting, it is then evaluated and then input is equal to this whole thing. So when I say input, what's happening here is eval of raw input. That's what is happening, which means whatever the input function is reading, whatever string I am reading, Python is trying to evaluate this string. The problem here is this string can't be evaluated. This string is not a valid expression, right? Then I said, okay. Then I said, I don't want the eval. So how do I get rid of the eval? The simplest way I get rid of the eval is by using raw input instead of using, because when I use raw input, there is no eval. It's not evaluating whatever input it is getting. So instead of using input, I used raw input and it worked for me. But I understood why it is working. Remember, your objective is not just to Google search, find some code, paste it, fix it. Your job is also to understand why something is working and not working. That's the only way you become a better programmer in the long run. Right? Thankfully, somebody mentioned this in the comment section. Actually, I got this, but because of the whole Python 3, Python 2 mix up, I think we missed some of that. The notebook that I'll share with Python 3. Okay. Sounds good. So this is cool. This is resolved. Okay. Let's go back to the question that we have. How do we represent a rectangle? I want to see some of this. Okay. How do we first before we go, how do we represent a rectangle? That's my question. How do we represent a rectangle? Let me see. Range the so somebody says you will check x1, x2, y1, y2. What are x1, x2, y1, y2? That's how do you represent this? Oh, there are also other ways. Chinmay, very good. I'm happy you said this. You can use the map with float. So what this does, this is a very nice thing that he pointed out. So you can also use the map function. So what this does, it's a very nice thing that Chinmay put here. It's a very nice thing. So what he wrote here, let me write it for you. He wrote for the previous problem. Okay, for the previous problem he wrote map. So you're going to map with float. Let me see the exact syntax. Input split. Okay, cool. So input split. So what this does, again, I'm assuming that you guys know what map is. This is also a very nice way of doing it. So you get the input or raw input, whatever you want, you split it. Then what do you get? You basically get a list of words. On these list of words, you want to apply the float function or the float data type conversion, right? Which is nothing but the float function on each of these entries. When you want to execute this on each of the entries here, instead of writing a big for loop, you can just use the map function. This will give you basically now the float values instead of giving you string values. This is also a nice way. This is a good way of doing it. Good. Thanks Chinmay for pointing that out. It was a good one. So, okay, how do we represent? Let's go back to the problem at hand. How do we represent the rectangle? What is the simplest way to represent it? There are many ways. By parallel lines, okay. 4 coordinates using what? Somebody says I just need 4 coordinates. Okay, can we, so one way is, okay, let's go through each of these, right? So one way is line 1, line 2, line 3, line 4. The problem with that representation here is, look at this, line 1, line 2, line 3, line 4. So to determine whether this point is within the line, within this rectangle or not, I have to determine that for this line 1, it is on the right side. For this line 2, it is on the left side. For this line 3, it is bottom. For this line 4, it is top, which is much more cumbersome. Can we do something much more simpler? Can we do something simpler than this? So somebody said, someone else said, we'll just use the 4 coordinates, right? So the coordinates here, the coordinates here, the 2 coordinates, the xy coordinates, the xy coordinates here, the xy coordinates here, the xy coordinates here. This is certainly possible. Here you have 8 numbers, but we know that it's a rectangle, right? Which means we know that this is perpendicular, this is perpendicular. We know that. Do you actually need all the 8 coordinates of all the 4 points? Can you be done with only 2 points? Do you really need all these 8 numbers here? 2 coordinates for each of the points. Can we do it with something lesser than that? 2 diagonals. Cool. That's good. That's it. So imagine if I just have top left corner and bottom right corner. It's a very simple problem, right? Suppose imagine if I have, this is top x coordinate, top y coordinate, top left, right? This is bottom x, bottom y. Just 4 coordinates. Because when I have the 4 coordinates, these coordinates have to be bloody well behave the way I want. Because it's a rectangle. It's not a trapezoid. It's a rectangle, right? So if I have a point here, px comma py. Now what is my rule system say? It's all that I have to do here is, I have to ensure that the px is greater than tx and px is less than bx. Then this point, look at it, that's one. The second thing that I have to ensure here is that this py is less than ty and it is greater than by. So it is greater than by, it is less than ty because it has to be below this line, right? This has to be greater than this, it has to be less than this. That's it. 4 checks, you're done, right? So the simplest way to represent a rectangle is by just using 2 extreme diagonal coordinates, and by just using greater than, less than concepts, you can simply check whether a point is within the rectangle or outside the rectangle, right? So very simple. Yeah, somebody wrote the code. Thankfully, it's a simple thing. I'm sure you can figure it out. That's the assignment problem, right? So please take it up and do it. Next thing, one of the biggest errors we see. I don't think we have half an hour, right? I have like tons of stuff to cover. Anyway, let's not jump. Let's not be in a hurry. Let's just go smooth because we have a session tomorrow, right? We can do as many sessions as we want. Okay. So, okay, the next thing that I want to run through is one of the most common mistakes that we see. Just give me a minute break. I just want to drink some water. Okay, so very common mistake we see because NumPy ND arrays are used extensively throughout machine learning, deep learning, all of that stuff, even TensorFlow, all of these guys use it. We see simple manipulation operations being messed up. This is one of the most common error messages that students encounter, and students send us an email saying, I got stuck here. But this is very simple if you're careful, right? NumPy manipulations are extremely simple. Let's start with something. The first type of operations where we see a lot of errors are reshaping matrices, right? There are these 3 operations where we see a lot of errors: reshape, hstack, vstack. Okay, these are the 3 errors that we see. We see every day at least 5 or 10 emails with just these errors. Literally, just with these 3 errors. I think even more than 10 emails. Forget 5, 10. I think more. Just these 3 errors is like 10. Easily 10 plus emails every day for us, right? That's why I wanted to go through it so that, I can see that many people are making these mistakes, right? So again, we have talked to some of our students. This is where they get errors, they get stuck, all of that. So I wanted to go through these. First, let's focus on reshape. Okay, let's take a matrix A. Okay, I'll show you some examples. Again, very importantly, we'll go through documentation. There is no escaping going through documentation. Please understand that, okay? So I'm creating a matrix, right? This is 5 rows, 4 columns. We know how to do it. I'm printing this. This is my this thing. Now, if I want to convert this, so first task that I want to do is, this is a 5 cross 4. My A is a 5 rows, 1, 2, 3, 4, 1, 2, 3, 5 rows, 4 columns. Right? This is my matrix. It's a 5 cross 4 matrix. First, I want to convert this into an array. I want to convert this into, again, remember that this is a 2D array. All these are ND arrays. All these are Numpy arrays, right? I want to convert this into, so I want to convert a matrix to a vector. We do this so much in deep learning. We do this like in so many places, converting a matrix into a vector. Very common operation, right? Now, when you want, so how many values are there? There are 20 values here. Let's just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. Okay. Suppose if I want to do it, how can I convert this? I've discussed this in the course videos also, row major, column major, order, all of that stuff. Very simple concepts, right? So one thing that I want to do is, first I want to reshape this into a vector. Remember, the first task is, given a matrix, I want to reshape it to a vector. When I say vector, it means just 1 row and 20 columns. This is a vector for me. Again, this is a row vector. I can also create a column vector, right? Let's talk about row vectors in this context. Again, we'll discuss row vectors, column vectors when we do some problems and some code examples with linear algebra, right? First and foremost, okay, reshape, okay. The moment before you use reshape, first you should read the documentation. It's a beautifully written documentation. I've pasted it here. So whenever you have a problem with reshape, please read what it is. Okay, so numpy.reshape. It's lengthy, but please be patient. Reading this will save you lots of time. First input is an array, an ND array that you have to reshape. Okay, the second is the shape that you want, the new shape that you want. It could be an integer, or if you want it, it could be a tuple of integers. Suppose if I want my 5 cross 4 array into just an array of matrix, 5 cross 4 matrix into an array of size 20, right? 1D array. I can just give an integer here. But if I want to convert 5 cross 4 into 2 cross 10 matrix, look at this, there are 20 elements here, there are also 20 elements here, so I should be able to convert it. If I want to do this, this 2 comma 10 should be passed as a tuple of integers. That's important. That's what it says. Again, you can read this whole thing. There is a special case also here. Very interesting special case. Read it. You have to read it. There is no escaping that fact. Okay. The new shape should be compatible with the original shape. What does that mean? 5 cross 4 can become 2 cross 10. But can 5 cross 4 become 6 cross 3? No. There are 20 elements here. There are 18 elements here. That's what this means. If an integer, then the result, if you just give one integer like 20 here, the result will be a 1D array of that length. Very simple to understand, right? One shape dimension can be -1. This is a very important thing. Suppose if I have 5 cross 4 and imagine, because if I want to convert this into 2 cross 10, let's assume I want to do that. What can I do? I can give the shape parameter as 2 comma 10. I can give this tuple. It's a tuple of integers. This is one way. Or I can say 2 comma -1. When I say 2 comma -1, the 2 is fixed. Whenever I give a negative, what does -1 mean? It means it's illogical. How can dimensions be negative? So what -1 here means is, okay, in this case, the value is inferred from the length of the array and remaining dimensions. If this is -1, this value will be inferred based on what this should be. We are not explicitly giving it. There are 20 elements here. If I have 2 rows, how many columns should I have here? I should have 10 columns. Now, if you give -1, Python or Numpy internally resolves that this should be 10. It resolves it without you having to explicitly write that. So whether you write 2 comma 10 or 2 comma -1, it is the same thing. Again, I'll show you examples of all of them. Let's go through the examples. Again, you can use C, F, A. C basically means row major order. F basically means column major order. Again, Fortran-like order. Fortran-like order is nothing but column major order. C-like order basically means row major order. I'll revise these concepts right now, right? What does it return? It returns a reshaped ND array, right? This is clear. Reading documentation is super duper important. So let's go and do a lot of examples now, okay? So this is my array. So what am I doing here? I'm saying print np.reshape. I want to reshape A because I want to convert the 5 cross 4. Look at this. I want to convert the 5 cross 4 to 1 cross 20. 1 cross 20 is basically an array of 20 elements. I don't have to give 1 cross 20. I can just give one integer because it will create a 1D array as the documentation says. The documentation says that clearly, right? If you just give one integer, where does it say? Okay, one shape dimension, it's here. If an integer is given, the result will be an 1D array of that length. It clearly says that, right? So what do? I just give it A20C. C here, you can read the documentation, gives you row major order because C programming language uses row major order. If you give F, you get Fortran-like or column major order. Let me explain what row major, column major as a quick recap. So when I do this, look at this, I print it. I always print, right? So what do I get? What is my first? Again, this is just one array. Remember, this is just one array. This notation is not there. Square braces within square braces is not there. Just one square braces. Okay, be careful. Now, first I get this value, then I get this value. Keep noticing this value is same as this value is same as this value. Then I get this value, then I get this value, then I get this value, then I get this. So what's happening? What is row major order? First I process the first row, add the first row here, then the second row, add it here, right? Then the third row, then the fourth row, then the fifth row. That is what is called as a row major order, right? Simple, very simple, no issues. Now, if I want column major order, let's look at this is my A. If I want column major order, we just read the documentation, right? It says you just say Fortran-like representation or column major order. When you do column major order, what happens? It will read this, followed by this, followed by this, followed by this. You can see the numbers here. First is 148. Next is 763. 763 is the next in the same column. First it's doing the first column, second column, third column, so on and so forth. This is one way. Cool. Very easy. Now, okay, so I have transformed my 5 cross 4 matrix into a 1D array. Now, if I want to do it as 2D array, let's see. So, if I want to do 5 cross 4 into 4 cross 5, how can I represent 4 cross 5? There are two ways of doing it. I just showed you, right? One way is to represent it as a tuple. We have seen people who don't represent it as a tuple. So, we have seen people who also put it in square braces. We have seen people who put it in curly braces. No. How do you represent a tuple? You represent a tuple using simple parentheses. The documentation is God. As far as code is concerned, documentation is the truth. Okay, it's your Bible, Gita, Quran, whatever you call it, right? It's your absolute truth. Okay, so that's one way. So I can write it 4, 5. I can also write it 4, comma minus 1, as I just showed you. When I do 5 cross 4, I'm writing it as 4, comma 1. Sorry, 4, comma minus 1. Then what does it do? 4, there are 20 cells here. There are 20 values. 4 is fixed, which means this will be 5. It will automatically interpret that. So look at this. I wrote 4, comma 5 explicitly, 4, comma minus 1. Both the results are the same. Just wanted to show you that. Right? The next one. If I want to reshape, look at the other way. The other way is also very interesting. So I can use the minus 1 here. Just like the way, see, I have 5 cross 4. I have written 4, comma minus 1. This worked. This is equivalent to 4, comma 5. The other way of writing it is, what if I wrote minus 1, comma 5? What happens? Whatever dimension is there, it will keep it the same. Right? Whatever this dimension, it will keep the same. The other dimension, it will try to interpret. This is 20 cells here, 5 here. So this should be 4. So 4, comma minus 1 is same as minus 1, comma 5 here. Look at this. They both are equivalent. You can look at the results also. They're exactly the same. Now, let's do one more thing. Okay. So I have 4 cross 5. Let me try to reshape this. My A, remember, my A is 4 cross 5. Sorry, 5 cross 4. I'm sorry. My A is 5 cross 4. I'm trying to convert this into 4 cross 6. This should give an error. Obviously, it will give an error. It gives me a value error and it says cannot reshape an array size 20 into shape 4, 6. Very clear message. Don't worry about all of this. This is so clearly written. This is all the internal functions that Python has a problem with, right? This is actually C syntax. PYC basically means the C file in which these things are running and things like that, right? Very simple, nothing fancy. Now I want you to do a thing. Okay, so as a simple exercise, again, reshaping is a very simple function. We see a lot of people doing mistakes, either because of the -1 confusion, again, that's a very common confusion, or the incompatibility, very common mistakes. And instead of using C, using F, instead of using F, using C, all of those mistakes. Okay, just be careful. Now, the exercise problem that I have for all of you is very simple. Very simple problem. Okay, the problem here is take a tensor of size 4 cross 5 cross 6. Again, I'm not saying an array. This is a 3-dimensional array. It's a tensor. And convert it into a, so look at this, and convert it, okay, so do things. Okay, so I have a tensor of size 5 cross 4 cross 6. First, convert it into a 1D vector. Convert it into a vector. That is first task. Convert into a convert the tensor. I think there is a small typo here. I should correct it. Take the tensor, convert it into a vector first. Okay, just 1D array. Then also convert it into a matrix, a 2D array. How many values are there? 4 into 5, 20 into 6 is 120 cells are there. So I can always convert a 3D, again, this is a 3D array or a tensor. I want you to convert into a 10 cross 12. Again, generate a random tensor of 4 cross 5 cross 6, should be simple. Convert into a 1D vector, should be one line code. Convert into a 2D matrix of size 10 cross 12. Very simple. This is one very common error. The second thing is stacking. Now let me show you stacking and how. Again, I think we'll finish stacking and then, yeah, I think we can finish stacking 3D tensors. Yeah, so problem 4 and 5 are very interesting problems. We'll discuss them tomorrow. Okay, so 3, let's finish it because anyway we are at it. Okay, so the next thing, this is a very common error again. Okay, so next is stacking. So let's look at stacking. Again, we have explained this in the course videos, but let's, again, very common mistake. I know a lot of people commit this mistake, right? So let's assume I have a matrix A which is of size 5 cross 4. I have a matrix B of size 5 cross 2, right? Remember, A is 5 cross 4. Okay, so 5 rows. Okay, let's 5 rows and 4 columns. Okay, this is your A. Your B here is 5 rows, ding ding, and 2 columns. Simple. Okay, this is 5 cross 4. This is 5 cross 2. Simple, cool. I've just printed them. 5 cross 4, 5 cross 2. Now, if you want, okay, so very common problem that people commit, very common mistake that people commit is, if I want to create a matrix C, look at this, I want to create a matrix C wherein I am joining this matrix with this matrix. Look at this, this and this, I can actually pull these two. I can pull this and combine them. Because there are 5 columns here, there are also 5 columns here. So these 5 columns will match with these 5 columns. So if I pull this towards this and if I pull this towards this, they both will form a coherent structure. Right? Now if I try to do the other way, okay, so this is what is called as horizontal stacking. Because what are we doing here? This is what is called as horizontal stacking. Because I'm moving this horizontally and concatenating them actually. I'm actually concatenating them, literally. But concatenating them by stacking them horizontally, right? So how do I do that? So there is a function called hstack, okay? Again, I've done mistakes intentionally, okay? So, okay, so this concept is clear, right? You understood that I can horizontally concatenate them. Can I concatenate them vertically? Think about it. Suppose if I have this, can I take this and place it under this? If I try to place this under this, what will happen? It will create this. It will create 1, 2, 3, 4. I can't combine both of them. What happens to these cells? What is the resultant matrix size? So I can't vertically stack. This is called vertical stacking because I'm stacking B under A. Vertically I'm trying to stack them. So A and B, I can't vertically stack them. I can't vstack. There is a function called vstack also. There is hstack. So if you look at these dimensions, it is very clear that you can horizontally combine them or stack them, but you can't vertically stack them. Okay, let's look at the problem mistakes that most people commit. Okay, this is a very common thing that we see. np.hstack a comma b, c equals to that, print it. Okay, now look at this. First thing, the error is so beautiful. The error says hstack takes exactly one argument. 2 are given. That's why I can't work. First thing you should do in such a case is read the documentation for hstack. Hstack numpy, that's it, just type hstack numpy. So what does it say? Let's look at the documentation, right? It says, what is the first? It says, okay, numpy.hstack, the parameter is called tup. What is tup? TUP is a sequence of ND arrays. It's a tuple, right? It's basically a tuple. TUP, the name itself says that it's a tuple. So what should work here? Look at this. Instead of this, what I should pass is the parameter. I'm passing 2 parameters here. It takes exactly one argument or one parameter. I'm giving 2. That's the error. So just go to the documentation. It says you have to pass a tuple. Just concatenate these 2 and pass a tuple. You're done. Look at what it has done. These first 4 columns are from A. These second 2 columns are from B. This is your A, this is your B. Your A and B have been combined horizontally or stacked horizontally. Works beautifully well. Very common mistakes, right? Again, you should always look at what is the function argument type. Read the documentation, see what it is. It takes less than 10 seconds to fix some of these bugs if you're careful. Of course, you become good at it over time. Okay, I could do it probably in 10 seconds. You might take 2 minutes, but 2 minutes, that's all. Okay, so now let's go here. Okay, so again, I created 2 matrices now, 5, 4 and 4, 4. Okay, look at this. So I have 5, 4, A, B is 4, 4. Can I stack these? Think about it. There are 5 rows here. Okay, so there are 5 rows, 1, 2, 3, 4. Okay, the 5 rows and 4 columns. What is B? B is 4 rows and 4 columns. Can I horizontally stack them? If I try to horizontally stack, these 2 will align. Okay, let me change the color here. These 2 will align, these 2 will align, these 2 will align, these 2 will align. What will this align with? Nothing, there is nothing to align with. Right? So if I try to hstack this, it gives you an error. I print A, I print B, C, it will give me an error. What error does it give? Let's read it. All the input dimensions except the concatenation dimension must exactly match. In our case, they are not matching. Look at this. These 2 should match. So except what are we concatenating on? So if this was 5 cross 4 or 5 cross 10, whatever it is, they're not matching. That's the problem. And you can see it by just drawing it. So hstack doesn't work here and gives this error. This is a very common error. Now, instead of hstack, what if we do vstack on this? Okay, look at this. So these are the 2 ones. I'm not able to hstack, but can I vstack this? Okay, let me draw this. Okay, so 4 cross 4, if I place 4 cross 4 here, how does it look? Okay, 4 rows and 4 columns. This is your A, this is your B. I can comfortably vertically stack them. So vstack is okay, hstack is not okay. Why is vstack? Because the columns are matching perfectly. For every column, there is a corresponding column here. So when I do vstack, everything works. Simple. Always, again, for vstack also, you have to ensure that the arguments are given as a tuple, not A comma B outside. If you don't have this parenthesis, it will give the error again. Let me just remove that and show you. You run this, it will give an error. Exactly one argument, 2 are given. Same error that we saw a while ago. Right? So just be careful with those errors. Okay, so this should work. Now, the fun part is what happens with 3D. With 2D, it's very simple. With 3D, things go crazy. This is where we see some errors also, especially in deep learning. Okay, how do you interpret again, 2D is very simple to visualize. What happens with 3D? Actually, when do you use 3D in machine learning? So if you have an image, right? An image is basically a bunch of pixels, right? Image is basically a bunch of pixels. That's what an image is, right? An image is basically a bunch of pixels. For each pixel, to represent color, you require 3 colors: red, green, blue, right? So your image is basically a bunch of pixels. This is your height of the image. This is your width of the image in pixels. But for every pixel, there are 3 values. There is R, G, B. And we represent that with a tensor like this. We represent with a tensor. And how do we represent that? It's very ingenious actually. The way we represent it is, for each cell, this is a cell, right? I have actually 3 values here. If you think, I have 3 values corresponding to this cell. The first value is the red value, the second is the green value, the third is the blue value. So this is how images are represented as tensors. You have the height, so this tensor is the height of the image in pixels, the width of the image in pixels, and the depth is 3 because it's a color image. Height, width and depth. Okay, this is height, this is width, this is the depth of the image. So to understand hstack and vstack for 3D tensors, it's very easy to imagine that with images, and that's what it was actually designed for. Okay, let's understand that. Imagine I create an image with 5 rows, 4 columns. Look at this. 5 rows, 4 columns and 3. Depth 3. Depth 3 basically means 3 colors. Right? This is the height, this is the width. Okay, simple. This is my, again, what am I doing here? I'm just creating a random matrix here. That's all I'm doing here, to be honest, right? So, okay, let me find a brighter color. Oh, I got the red. Good. Then I have my B. What is B? B is 5 cross 3, 3. This is the height, this is the width, this is the colors. Simple, right? This is my, okay, so let me just try to use a different. So my A is 5, 4, 3. This is the height of the image, width of the image, the depth of the image, or the number of colors. This is my A. Okay, what about my B? My B is 5, 3, 3. Now if I do a hstack, will it work? I have 3 dimensions now. Again, even drawing this is a little cumbersome. So the way you have to think about it is this. When you're doing hstacking, imagine if I have an image like this, okay, with some depth, with some depth, right? Again, the depth here basically means colors. Okay, suppose if this is my first image, okay, this is my A, image A. 5, height 5, this is 4, the depth is 3. I have B. B is again 5, height of 5, the height is the same. Look at this, the height is the same. The width is 3, the depth is also 3. So what is hstacking? Hstack basically means horizontally combine them. So if I have 2 images represented as 2 tensors like this, can I combine them horizontally? Yes. Why am I able to combine them horizontally? Because the depth is the same. Look at this, I'll combine these 2. Suppose if this is an image of a face, this is an image of, let's say some, tell me something, some cricket bat, okay, whatever. I'm very bad at drawing, okay. If I combine both of them, what do I get? I draw like a wine bottle, sorry. So, yeah, some cork, whatever, okay. Suppose if I combine both of them, what do I get? I get a face, next to it, I get a cricket bat. I can combine these 2, right? Because the height is the same. Look at this, the height is the same, the depth is the same. So I can combine them horizontally. So when you're applying hstack on 3D tensors, we don't do much of 4D tensors much, but 3D tensors are important. Now, are they both compatible? Yes, they both are compatible. What should be the result here? Think logically. What should be the result here? This should stay 5. Again, if both of them are horizontally combined, I'll get 5, comma. What happens to my width? This is 4, this is 3. So my width becomes 7, my depth stays 3. That's what happened here. My A is 5 cross 4 cross 3. My B is 5 cross 3 cross 3. My C is 5 cross 7 cross 3. So hstack works. But if I try to do a vstack, okay, we'll go to vstack, okay. Let's do a different example, right? Suppose if I have my A, which is 5, 4, 3. Okay, this is 5. This is 4, the depth is 3 anyway, okay, depth is 3, okay, I'll just keep 3 as is, plus, okay, what is this? This is hstack only, no, so not plus, hstack, 4 cross 3 cross 3. Now, can I combine these 2 horizontally? Look at this. My depth is matching. Cool. There's no problem with depth. But this image height is 4. This image height is only 5. If I combine them, there will be some gap that is created here. So I can't combine them horizontally. That's why when you try to do this, it will give you a value error and it will simply say, sorry, all the input dimensions should be same and concatenation cannot be done. Very simple concept. Similarly, okay, let's look at another example. Okay, so here what do we have? 543 and 542. Can you combine both of them? You can't, because the depth is not matching. Everything, again, this is also image concatenation. Imagine if I have an image with 3 colors, 5 cross 4 and 3. This is 5 cross 4 cross 2 for some reason. I can't combine them, because if I try to horizontally combine them, these cells will have 3 values here. These cells will only have 2 values. So I can't horizontally stack them. This is very important. Okay. Again, I'm just giving you multiple examples. Now, can you vstack it? How does vstack work? Let's see. Okay. So one of my matrices is 543. Okay. So this is my image. Always it's easy to think in terms of images. Height, width, and this is 3. Depth is 3. What is height? Sorry. Let me, instead of writing height and width, let me just call it 5, 4. Right? 5 and 4. Can I vstack this with? Can I vstack this with 2, 4, 3? Let's draw. Vstack, right? So vertically stacking. So depth is 3. So this 3 and this 3 are matching. So I can combine them. Cool. This is 2. This is 4. Because this is 4, I can combine. So look at this. Think of this as 2 cubes that you're trying to join vertically. The easiest way to think about them is 2 cubes that you're trying to join. Do they fit well? Yes, the depth here is 3, the depth here is 3, which means it will fit. Here the width is 4, the width is 4, it will fit. So when the whole concept of hstack and vstack, the whole compatibility of hstack and vstack is by combining 2 rectangles, either vertically or horizontally, are you able to create another rectangle? This is with 2D. With 2D, are you able to create it? If you can, there is no issue. If you can't, suppose if you have an issue like this, one rectangle is like this, one rectangle is like this. The final result is not a rectangle, then it will give an error. Similarly, with 3D tensors, instead of rectangles, now we are working in the space of cuboids. Can you combine these cuboids? Vertical stacking means this is vertical. The previous one, combining them like this is horizontal stacking. So by combining horizontally or vertically, can you create a cuboid again? That's the whole point here, right? I hope this is clear. Again, now the exercise problem I have for you is this. The same thing that we have done with hstack and vstack. Actually, if you go to the documentation of hstack, okay, go to the documentation of hstack. It says, if you read this, the functions concatenate, stack, and block provide more general stacking and concatenation operations. Okay, hstack is horizontal stacking, vertical stacking. There are more general functions like concatenate. Okay, I want you to implement whatever we have done above, both 2D stacking and 3D stacking, using the concatenate function now. Again, the concatenate function reference is here. It tells you what is, again, read the reference. I've given the reference here also. Please go through this. I want you to implement and try out the concatenation, the hstack and vstack operations using concatenate. And the objective here is that you know in another way of doing the same stacking thing, and concatenate is much more generic and much more powerful. But of course, you have to be more careful also, right? So what I'll do, again, there are 2 more problems and sub-problems that I wanted to discuss. I'll discuss them tomorrow. Most importantly, the only way you become good at programming is, I'll share this whole document, even problem 4 and 5 that I'll discuss tomorrow. Hopefully we'll discuss problem 4, 5, because we have discussed so many errors and how to debug errors. We can speed up now. Tomorrow, let's try to discuss 5 to 6 problems. Okay. I'll do 4, 5. I'll do 6, 7, 8 also. Right. So let's try to do that. Very importantly, some of the students in the comment section asked us about practice. Right. So here are a bunch of problems, optional assignments at Applied AI course. Please go to this document, download it. There will be a bunch of problems. Again, this document is all, I think, some 15, 16 programs related to functions. Again, we have one for pandas, but there are lots of online resources. Okay, I really love this resource. This is Python exercises for Numpy. Beautiful resource with tons of practice. Literally, like, look at this. There are 41 exercises with Numpy basics, 192 exercise problems with Numpy arrays. The diagrams are also beautifully drawn. I love this website. I just bumped into it while searching. Right? I was looking for some sample problems. Tons of problems. There is also sample solution given. The only way you become good at programming is by practicing. If you just listen to what I'm telling you now, you don't become a good programmer. I'm only giving you a direction with a few examples. If you want to practice a lot of Numpy problems, there are hundreds of problems here. Try to at least solve a few. If you want to do a bunch of basic Python programs, Geeks for Geeks has a good collection. I really like this collection because it starts very simple. It starts with Python program to add two numbers, Python program for factorial of a number, Python program for simple interest. It starts with these problems and goes on to slightly more complex. And there are tons of problems here. There are a bunch of problems on dictionaries. So if you want problems for practice, there is no dearth of them. All you have to do, again, please understand that if you want to become a good programmer, you have to practice. I don't want to tell numbers because different people have different aptitudes. Different people come from different backgrounds. So I would say you should reach a position where given a problem, you can break down the problem. Again, I have some problem on permutations, combinations, some problem on finding peaks in a list, bunch of interesting problems. I'll share this whole document with you. Right after this, I'll put it in the comment section of this video itself and also in the description section. But if you want to practice more problems, here they are, right? So please, again, see you tomorrow at 6 p.m. I know I couldn't cover everything, but I hope, again, please let me know how you think about this methodology. Again, please understand that today we are going slow because we are in the starting. Today we could only do 3 problems because for every error, I went through the documentation, read the documentation for you, explained it. Slowly, I'll go through every line of code, but I may not be able to cover every error. I'll try to cover most errors, but in the interest of time, we have done 3 problems today. Let's try to do 5 problems tomorrow. Of course, the complexity of problems also will increase. The next problem itself is given a list like this, find the peak numbers. Again, I describe this. There are also external references that I give for some of these, right? The next problem is given a list like this, print all the permutations. So I slowly increase the complexity of problems, right? So again, see you tomorrow at 6 p.m. We're doing it today, tomorrow, and the day after. The rest of the plan, I'll let you know as we progress, based on our speed of progress, right? So see you folks. Bye-bye.